Okay, so if I wanted to look at this number, 3,456, and I wanted to say, is it divisible by 9, we would do the same thing. It's the sum of the digits. So 3 plus 4 plus 5 plus 6. 3 plus 4 is 7. Okay, 7 plus 5 is 12. And then 12 plus 12 plus 6 equals 18. 9 will go into 18 evenly, so that means this number is divisible by 9, and it will have no remainders. Okay, factors are a whole number that multiplies one with another number to make a third number. So factors are the numbers multiplied together to make a third number, which is the product. Okay, composite numbers. A composite number is a whole number greater than 1 that has more than 2 factors. Okay, meaning I can multiply it multiple times. Okay, prime numbers, a whole number greater than 1 that has exactly 2 factors, and they are 1 and itself. All right, so just remember that. Okay, multiples, or the word multiples are is where you're skip counting. Divisible means it's divided evenly with no remainders. Okay, so just think about those things when you are looking for your factors. Okay, and I'm going to do some more examples. But first, what we're going to do is we're going to fill in a divisibility. A prime and composite chart. Okay, so we're going to fill this in using the divisibility rules. All right. So the first thing that we know about the divisibility rules is that 2, any number that is even, is divisible by 2, except for the number 2. Remember we said the number 2 was the only prime number that's even. And then we said the number 1 is neutral. Okay? All right, so every number that ends in a 2 is going to be divisible by 2. So I'm going to draw a line straight down because those are all composite numbers. 4 is the next even number. All the numbers that end in a 4 are composite. 2, 4, 6. All the numbers that end in a 6 are composite numbers. Okay, 2, 4, 6, 8. All the numbers that end in 8 are composite numbers. 2, 4, 6, 8. 10. All the numbers that end in a 0 are composite numbers. Okay, all of these that we have highlighted right now are divisible by 2. Okay, all of the numbers that are highlighted at this moment are divisible by 2. All right, then we're going to look at divisibility rule for 5 because that's quick. The rule for 5 says if the last digit ends in a 5 or a 0. Well, all of these end in 5, don't they? But the number 5, the only way to make 5 is 1 times 5. So it is actually a prime number. Okay? But all of the other digits that end in 5 are composite because 5 goes into all of those. And then we already have the zeros done. All right, so now what we just have to do is we have to go through and look, and we have to ask, will this number go into 3? Did the sum of the digits, is it divisible by 3? So let's look at each individual set of numbers. Okay, so let's start with 3. Well, I know the only way to make 3 is 1 times 3. So 3 is a prime number. The only way to make 5 is 1 times 5. The only way to make 7 is 1 times 7. 9, I know 3 times 3 equals 9, so that would be a composite number. 11, 1 times 11, it's a prime number. 13, 1 times 13, it's a prime number. 17, 1 times 17, that's it, it's a prime number. 19, 1 times 19. Okay, 21, 7 times 3 equals 21, because 2 plus 1 equals 3. 3 will go into that. 23, 2 plus 3 is 5. It's a prime number. 27, 2 plus 7 is 9. So I know 3 and 9 will both go into that. 29, 2 plus 9 is 11. Prime number. 31, 3 plus 1 is 4. Prime number. 33, 3 plus 3 is 6. 3 goes into 6 evenly, so it is a composite number. 37, 3 plus 7 is 10. It's a composite number. 3 plus 9 is 12. 3 goes into 12. So right now we're just looking at the 3s. As we get bigger into our factors or into our chart, we're going to have to look at a couple that we just know are called tricky 7. So we'll get to those in just a second. 41, 4 plus 1 is 5. 41 is prime. 43, 4 plus 3 is 7. Prime. 47, 4 plus 7 is 11. It is prime. 49, 4 plus 9 is 13. But I also know that 7 times 7 is 49. So that makes it a composite number. Okay. 51, 5 plus 1 is 6. 3 goes into 6 evenly. 53, 5 plus 3 is 8. It is a prime. 57, 5 plus 7 is 12. That makes it a composite number. 59, 5 plus 9 is 14. It is a prime number. Okay, 61, 6 plus 1 is 7. It is a prime number. 63, 6 plus 3 is 9, making it a composite number because 3 and 9 both go into it. 67, 6 plus 7 is 13. It is going to be a prime number. 69, 6 plus 9 is 15, making it a composite number. 71, 7 plus 1 is 8. It is a prime number. 73, 7 plus 3 is 10. It is a prime number. 77, 7 plus 7 is 14. But I know, tricky 7, 11 times 7 is 77. So that is a composite number. 79, 7 plus 9 is 16. It is a prime number. 81, 8 plus 1 is 9. That was one of our examples. That's composite. 83, 8 plus 3 is 11. It is a prime number. 87, 8 plus 7 is 15. Composite. 89, 8 plus 9 is 17. It is a prime number. 91, 9 plus 1 is 10. So I need to think about tricky 7. So, because I know that 7 is 77, plus 7 more is 84, but 7 more would make it 91, making it a composite number. Okay, 93, 9 plus 3 is 12, composite. Okay, 97, 9 plus 7 is 16. It is a prime number. 99, 9 plus 9 is 18. It is a composite number. So, all the numbers that are highlighted are composite. So, those are our composite numbers. All the ones that are circled are our prime numbers. Okay? All right. Then it says blank are whole numbers that multiply to make a product. Okay? That would be factors. Factors are the numbers multiplied together to make a product. Okay? Factors are the numbers multiplied together to make a product. For example, blank of 8 are 1, 2, 4, and 8. So that would be factors. Factors of 8 are 1 times 8 and 2 times 4. 1 times 8 equals 8. 2 times 4 equals 8. Blank numbers are numbers that only have 2 factors. 1 and that number. So what are the numbers that only have 2 factors? They're called what? You should have said, written down prime numbers. Prime numbers only have 2 factors, 1 in itself. Example, 5 is a prime number because the only factors of 5 are 1 and 5. Blank numbers are numbers that have more than 2 factors. So what has more than 2 factors? It is a composite number. Composite numbers are numbers that have more than 2 factors. 12 is a composite number because it has more than 2 factors. So 12's composite. This is kind of repetitive, isn't it? Anyways, so 12, I have 1 times 12, 2 times 6, 3 times 4. So the factors are 1, 12, 2, 6, 3, 4. 1, 2, 3, 4, 6, 12. Okay? All right, so that is your review for prime and composite divisibility rules. And now I'm going to give you a little assignment on... No, I'm not. I'm not going to give you an assignment yet. So now we're going to go over some T-charts because I want to make sure that you understand how to do the T-charts.